In question 3, we're asked to give ionic equations, so we need to remember the rules. Question 1, is it ionic? Question 2, is it aqueous? If it is both aqueous and ionic, then it can be split, otherwise it's going to be left as it is. So I'm going to use a different colour of pen, and we're just going to break things up so then we can see what we're left over with. So here we've got copper sulfate. Copper is a metal, so this is ionic. So it splits into 2 bits. The first word, copper. Copper ions are 2+ here. Because we know that sulfate ions are 2-. Then we've got sodium hydroxide, which contains sodium, so it would be ionic. We've got big 2 in front, so we would have 2 of each thing. Now the next thing is solid, so we do not split it if it is solid, liquid or gas, only if it's aqueous and ionic. Then we've got sodium sulfate, which is aqueous, so that would be ionic. It's got a sulfate ion in it, and it's got 2 because of the Na2. We know that a sodium ion is a 1+. We've got 2 of those. And then we're going to cross out things that appear on both sides. There's a sulfate ion on both sides. There's 2 sodium ions on both sides. And we're left with the copper ions reacting with the hydroxide ions to make copper hydroxide solid. And that's our ionic equation. So in the next one, zinc sulfate is a solid, so we're going to leave it as it is. Sorry, zinc oxide even. Now phosphoric acid is aqueous and ionic, because remember that acids are ionic. We've got 2 of these, so let's just think about phosphoric acid without the 2 to start off with. Phosphoric acid contains phosphate ions, and it contains hydrogen ions. All acids, the definition of acid, if we'd have asked you to state that one, would have been a substance which donates H+ ions in solution. Now this is donating H+ ions. Now one phosphoric acid has 3 of these, but we've got 2 phosphoric acids, so we've got 6 protons, 6 H+ ions, and 2 phosphate ions. Then we've got zinc phosphate. Now we have to remember that zinc is always 2+, but we can tell that because we know that if we've got 2 phosphate ions, which are 3-, which we should know, we must have 3 zinc 2+ ions to balance the charge. But then we've got water, and because water is a liquid, it cannot be separated into ions. And we're going to cross things out. So we've got the 2 phosphate ions on each side, and that's it. Now you might notice that we can simplify this, or you might just want to leave it. So you could leave it as 3ZNO plus 6H+, makes 3Zn2+, and 3 waters. Or you could simplify it down to 1ZNO and 2H+, makes 1Zn2+ and 1 water. Now our last example, we need to be more careful because everything's aqueous, so we feel like everything might cancel. But chlorine, Cl2, does not contain a metal and is not an acid. So that cannot be separated. It's a covalent substance. 2 sodium bromides, though, sodium is a metal, so we know that we're going to split that into 2 sodiums and 2 bromides. And bromine is a covalent compound. It doesn't contain a metal and it's not an acid. So it stays as it is, but 2 sodium chlorides get split, and then we're going to cancel down. So there, our sodium ions cancel out. Chlorine plus 2 bromide ions gives us bromine plus 2 chloride ions.